So welcome.
I think
Today,
we can come a bit
I
forward.
want to tell you about the story of Swisscom bringing regulated workloads to the cloud. This is session SEC205, and we are here with Nicolas Passadelis, Head of Data Governance at Swisscom, my colleague Marco Fischer, Senior Solutions Architect at Amazon Web Services and Lead Architect for Swisscom, and I'm Ruben Mertz, Principal Solutions Architect at AWS. And that is even working. Fantastic. That's going to be our red line for today. I'll tell you about the Swisscom and AWS partnership, and then I'll continue with a primer on security and compliance, because this is right where we started with Swisscom in 2021. Nicolas will then come on stage, and he will tell you the story of Swisscom, the story of adoption, of cloud adoption, of regulated workload, and how they remove roadblock. And then Marco will take the third part, and he will tell you about how you take our controls and you operationalize them in a blueprint that you can take to production. And we'll then close. I'm assuming that everyone in this audience and in the rest of the room on the side over there, by the way, knows Swisscom. Swisscom is the leading telecom service provider in Switzerland. It's a major IT provider. They have operations in Italy as well. And their vision is bold. It is to empower the digital future as an innovator of trust. Swisscom is a technology company. They're customer focused, and they've been there for quite some time. And that's right where lies their challenge. How do you transform? How do you adopt the cloud? How do you innovate, all at the same time keeping the trust of your customers when you operate in a regulated industry and a regulated environment? We're very, very fortunate to have Swisscom as a strategic partner since 2021. And we're super proud that today, Swisscom is operating mission-critical and regulated workload on the AWS region right here in Zurich. So let's start where we started back then with Swisscom in 2021, with security and compliance. That's going to be a primer. And I want to talk about 4 topics. The first one, and maybe some of you know it already, it's our shared responsibility model. It goes like this. Security and compliance is shared responsibility with us, AWS, and you, the customer, in that case, Swisscom. We take care of the security of the cloud. That's our global infrastructure, that's the software that powers it, and that powers all of our services. As a customer, you are responsible for the security in the cloud. Now, we have to make a couple of things clear here. What does it mean that you are responsible for the security in the cloud? Does it mean that you're alone? You're not alone. So first of all, at AWS, security is our top priority. It permeates everything that we do. From design discussions, when we go to the whiteboard, if we write design docs, how the way we build and deploy software, including the conversation that you might have with us as solutions architects. It's everywhere in our culture and in our organization. And as a customer, you benefit from that investment in security that we make for all of our millions of customers, including the most demanding one in regulated industries or in national security. You have access to a large set of cloud security tools, whether for data protection, for monitoring, and for detection, for auditing, and for validation, and especially, because it's the cloud, for security automation. We want to make sure that you can scale your security posture on the cloud. We innovate, okay? You benefit from our expertise in machine learning for security or for augmented reasoning. That's the first part. The second component is our infrastructure that's built in for operational resiliency. Today, AWS has 34 regions, global regions available worldwide, including one here, right here in Zurich. A region is a collection of at least 3 availability zones. And an availability zone is a collection of 1 or more discrete logical data centers, and the logical data centers has 1 or more discrete buildings, each with redundant power, connectivity, networking, housed in a dedicated facility. And that design, those capabilities, they allow you to build, deploy, and operate your most mission-critical applications with high availability. The third component are our technical cornerstones. So with AWS, you might have been exposed to the more than 200 fully featured services that we have. Across these, you'll find today more than 300 security features and capabilities and services. That's a lot to cover. We would need an entire set of sessions to go through that. And here, I want to give you a perspective on what we discussed with Swisscom when we started the discussion. I want to tell you about the AWS Nitro system. Has everyone ever heard about the AWS Nitro system? A bit of gymnastic with the hand? Some people, that's good. But I need all of you to hear about it. Then I want to talk specifically about encryption with the AWS Key Management Service. We could talk about other security service for data secret protection or for security automation, but I will focus on this one. Especially because that's the service that enables Swisscom to encrypt everywhere in all of the major services that they are using. That's EKS, that's Redshift, that's DynamoDB, that's S3. Everywhere they can use encryption. So let's start with the Nitro system. The Nitro system is the service that's powering our computing capabilities. It is a reinvention of our virtualization stack. What we did with Nitro was, if you're familiar with virtualization, is we took virtualization function and we moved them to dedicated hardware with specialized firmware. That architecture has many benefits. One of them, for example, is that we've decoupled the virtualization stack from your compute, and that allows us to innovate fast. Today, you have access to transparent, in-transit encryption between the instances that support them. That's one example. The other benefit is the very strong logical and physical separation that this architecture provides. There is no one, including at AWS, no one has access to the customer workloads. There is simply no operator mechanism built into the Nitro system. And in this context, transparency and assurance is of uttermost importance. And we worked with the global security consulting firm NCC Group on an independent attestation of the security architecture and of the claims that we make about operator access. That report is publicly available. I encourage you to have a look at it. You find it online. It was released last year. And that report confirms the security architecture and the absence of operator access. Now let's talk about encryption. And what we used to say at AWS is encrypt everywhere. So let me tell you about AWS Key Management Service, or KMS. KMS is our service to manage cryptographic keys and to provide API for encryption. You can use KMS with your applications. You have access to software development kits. Your application can be in the cloud or on-premise. And KMS is integrated with all the major AWS services, more than 100 of them. The architecture of KMS is highly available. It's also cost-effective. By default, KMS stores cryptographic material into a fleet of shared HSMs. That architecture is FIPS 140-2 level 3 certified. I have to be a bit precise here. And that certifications, again, ensures the absence of operator access. Nobody at AWS, including the most privileged administrator, can extract your cryptographic material in plain text. Now let's assume that you have a regulation or a legislation that needs you to have more control on the HSM hardware. That's possible as well. You can use our custom key store capabilities, and you can deploy AWS Cloud HSM that gives you direct access to the HSM in the cloud. Or you can also rely on your own HSM on premises with our extended key store capabilities. Now I need to call out one thing here. With great power comes great responsibility. When you do these things, you become solely responsible on the durability of your cryptographic material. So let me tell you in 60 seconds how KMS works. With KMS, you have the ability to create a cryptographic key. We call that a KMS key. You control the lifecycle of that key. With that key, you have access to API that allow you to encrypt, decrypt, generate and verify message authentication code, or sign and verify. Now that design, when you need to encrypt large amount of data, is not going to scale. In that case, our services are using a mechanism called envelope encryption. With envelope encryption, an AWS services that need to encrypt your data is going to use KMS to generate a data encryption key. That data encryption key is protected by the same KMS key that you created. Once the data is encrypted, the data encryption key is stored encrypted with the data. When another service needs to decrypt the data, it's going to make a call to KMS. Assuming that the key policy that you control allows the service to decrypt the data, decryption can proceed. Now, KMS is integrated with CloudWatch and CloudTrail, and that gives you full visibility over the key usage and the APIs that are being called. Okay, let's talk about the 4 components, and that one is assurance. At AWS, we have 143 security standards and compliance statements, and these complement the contractual commitments that you have with us, our data processing addendum, the Swiss addendum, and others. Okay? I will call out here, for example, the C5. I can call out the NCC Group third-party report audit that I already mentioned, and others. So let me summarize. The AWS infrastructure is sovereign by design right here in Switzerland. And I want you to remember 4 things. You have complete control of the location of your data. You decide where you store your data, and they stay there. You have verifiable control over data access. For example, thanks to the Nitro system design and its third-party attestation. You can, you should, and I would say you must encrypt everything everywhere in the cloud, and you have access to the most resilient and secure cloud infrastructure. With that, now that you have the primer, I'll give over to Nicolas. Thank you.
Turn it off? Okay. Thanks, everyone. Really excited to be here. Great crowd. And thank you for AWS for having me. A couple of years back, I was having lunch with a good friend of mine who's working in the IT industry. And he knew I was a data protection guy. And so he asked me, and he said, Nicholas, let's be frank. This entire data protection thing, aren't you overdoing it a little bit? And I said, no, I don't think so. And I told him a story. And bear with me, it's not a funny story, but it's important. In the late 19th century, early 20th century, all across Europe, governments were collecting data on their citizens. You know, they try to be more efficient, they try to organize themselves better, and as you know, data is always good to get organized. So in the Netherlands, they gathered all this data on their citizens, including religion. And so they had this wonderful register where everyone was registered, and the religion was registered too. And obviously they also had registered Jews, roughly 140,000. And then, as you know, in the late 30s, 1939, the German Streitmacht invaded Netherlands, and they found those lists. And you know what then happened? They actually worked through the list and identified all the Jewish citizens they afterwards deported. And the Germans were particularly successful, if you can say so, in doing what they did because they had the data. So when we talk about data protection, honestly, in my world, it's not about cookies and it's not about accepting cookie banners, etc. But it's about the real threats which are connected with data. And the real threats may not be lying today, but they may be ahead of time, maybe decades, as this example in the Netherlands shows. And one thing you always need to be aware when you work in digitalization is that with digitalization, a very fundamental principle of mankind changed dramatically. Up to the beginning of digitalization, the default was everything which is not written down will be lost as an information throughout history. And with digitalization, it's just the opposite. Everything which is not deleted will stay forever. And as you and I, we all don't know what's going to happen in 20, 30, 40 years' time. We don't know what's going to happen with the data. So we need to make sure today that we have data regulated and we do the right stuff with data as data protection requires us to do. So for us, that's the other way. So for us in Swisscom, and for me personally, about 3 years ago, that was a real journey to embark on the cloud. And I learned 6 lessons from that journey. Lesson number 1, we need to know our data and the tools we use to process the data. Then we need to know the laws which are applicable. Third, we need to ask ourselves, what do our stakeholders think if we embark on the cloud? Fourth, we need to understand the risks. 5, we need to master the cloud. And 6, we need to stay in control once we are on the cloud. I run through these 6 principles to get you a little bit more flesh to the bone what I'm talking about. Data, and especially data at Swisscom, is a hugely complex thing. I'm not sure if you know that we have all the data you can imagine. Why? Because we have the products we sell to the people. We have on the B2C side, we have lots of products. Many of you will use them. On the B2B side, we have a full-fledged IT business with outsourcing, managed services, connectivity, etc., etc. So by mere providing the tools and the products to our customers, we get the data because it's inherent in what we do. And to have a full transparency on what exactly we do, in which value chain we produce which data and the way we process it is a challenge in itself. However, once you go into the cloud, you need to know what you're going to do, what data is affected, what data isn't affected. And this knowledge we had to build up. We had to understand that knowing what we do is much more important than we thought in the beginning. The reason why you need to do this is because there are regulatory reasons to know it. I'll make an example for you. One question is, in which capacity do you process data? Are you the data controller? So you're responsible for making sure that data protection laws are complied with? Or are you the processor who processes the data in fulfillment of an agreement with a data controller? And this, in practice, is quite difficult to make the distinction for legal reasons I will not dwell into. And only this to know is a challenge in itself, especially if you have a very broad business. Then you need to check the laws. Now, many of you will say, well, come on, there are basically 2 laws. It's a Data Protection Act in Switzerland, and it's the General Data Protection Regulation of the EU. Correct? But if you have an international business, you may know that most of the countries in the world now have data protection laws which may be slightly different of what we know here in Europe. And then you may have secret data. What do I understand by secret data? For instance, if you have telecommunications data, then this is protected by telecommunications secrecy. You may be a bank, therefore you have banking data which is back to banking data. And I could go on like that. Then you say, well, good for me, I don't work in a regulated industry, so I don't have any secrecy data, and say, wait a minute, and think about this again. There are laws in Europe, but also in Switzerland, which protect business secrets of customers. So if you work for B2B customers, and they give you, let's say, within an outsourcing arrangement, they give you their crown jewels. Let's assume it's a pharmaceutical company who has stored their recipes on your server. These recipes are protected by secrecy data, in that case, business secrecy laws. And why is that important? it is important because all the secrecy laws in Switzerland and mostly around the world, they are protected by criminal law. So if you violate a secrecy law, you are criminally liable for this violation. And many of you will think that I'm the guy as a data protection officer in Swisscom hindering business. And I would say, no, that's not true. One of my prime goals in the company is to protect my colleagues from being liable criminally. Because criminal liability is always personal. So if one of my colleagues breaches a secrecy law, he or she may end up in criminal court and be convicted. And this is absolutely to avoid. Therefore, by making sure I know which laws apply, I protect my colleagues and the company on top of it. One point which is really very close to my heart is not a legal point, but it's a soft point. It's a psychological/social point. Ask yourself before going into the cloud what your stakeholders think. Why do I think this is important? As you know, the cloud is not something everyone thinks is great. There are a lot of people, and maybe even people in the audience, who have mixed feelings about the cloud for several reasons. And the same is true for our company. We are not a company saying, oh, we go all into the cloud. There is a sizable portion of our colleagues who think it's the wrong thing to do. Then if you get into the cloud, it will inherently cause reactions. It will cause reactions internally, but it will cause reactions also into the public. And if you're Swisscom like we are, then you may know that we are a little bit more under the spotlight in public than other companies. And one example to show you how that works out, probably about 2 years ago, you remember that the federal government had a tender for cloud services. And they came up with a short list, and I think there were 5 on the short list, if I'm correct, and one of them was Alibaba Cloud. Nothing decided, especially not decided what data would ever go to the Alibaba Cloud if they went. And it was not decided how this data would be protected. It was just on the short list as a potential. What happened in the media? The media completely freaked out. The day they went public, the next day you could read it everywhere where they say, the federal government goes to the Alibaba Cloud. It's Chinese. Don't you know the risks which are entailed, etc., etc. And it was utterly unfair because no decision had been taken. And therefore, you can see how detrimental the public opinion can be on your projects, even if you have done your homework. And therefore, it's important to ask yourselves, what do my customers think? What does the organization think? Maybe some other departments of the organization. Will there be public uproar? Because if you want to go into the cloud with a project which is absolutely perfect viable, but you get lots of headwinds from outside, it will kill the project. So it's good to ask yourself first, especially now for the federal government, they have obviously data which is subject to the official secrecy, so it's secrecy laws, and that obviously triggered this hefty reaction. One point which you always hear, it's understanding the risks. Now, what is important, and I had to teach our colleagues on this, each use case is different. I reckon roughly about 24 different elements which design the DNA of a use case. I'll make a little example so you can understand. Let's assume I have a CRM database which has maybe 10 million of customer data. To make it simple, it's name, family name, email address, and telephone number and address. Not a great deal, we would say, as data. I'll go into a cloud provider, and there's 2 hypotheses. Number 1, the cloud provider is in Frankfurt, Germany. Number 2, the cloud provider is in, let's say, Kazakhstan. No reproach, I'll just take it as an example. Question, is the risk profile different? By the mere fact that the location, one is Frankfurt and the second one is Kazakhstan. I will not ask you what you think, but I think there is a difference in the risk profile. So there's just one element which changes and the risk profile changes. So you need to know what is the DNA of my use case. And sometimes the DNA of a use case will make it impossible to go into the cloud. I'll make an example again. We work for the Swiss Army, the military arm of the federal government, and they have certain operations with us which will never ever go into the cloud. Full stop. So therefore, it depends really on the use case, and you need to know these use cases. And for us, this was not so easy to identify the risks. I don't know about you, a lot of people in my organization says, well, risk management is not my cup of tea. You know, that's other people who do that. I'm convinced we all should do risk management. We all should have a feeling on the risks. For instance, what are the provider risks? There are providers who are very mature in what they do, like all the cloud providers, the hyperscalers, but there are also providers who may not be that mature yet. So depending on where you go with your data, the risk profile may be different. Obviously, there are security risks, the plain vanilla security risk, you know all. And then there are the lawful access risk, one topic which is extremely discussed in the cloud business. What do I mean by lawful access? It's basically the hypothesis that there are foreign governments and foreign police enforcement, law enforcement agencies which actually have a grip on the data, including secret services, through the fact that they have national laws who allow them to do that. The examples everyone discusses is the Cloud Act in the US and FISA 702. FISA 702 is a law which allows mass surveillance by the secret services of the US, so the intelligence agencies. And again, you need to understand these risks to know whether it's okay to go into the cloud or not, to start with, or to say what measures do we have to take in order to make it work. Then we have data minimization risks. You should not put more data into the cloud than necessary. It depends on where the data goes. Does it go to Germany? You have other different other compliance measures than if it goes to Kazakhstan. You have the disclosure risks that the provider maybe has a data breach, and then you have the abuse risk where the provider may do things with the data you actually don't want to. This abuse risk is now discussed more regularly in the realm of AI. You know that they may take the data to train the algorithms, they may data to do analysis, etc. And maybe you don't want that depending on what data you have. So understanding those risks is important. But the key element of our journey, and it's actually my conviction, is mastering the cloud. What do I mean? This picture you see here is the board of a nuclear power plant. And I took it on purpose. Why? For me, having an operation on-prem is roughly the same, compared to the cloud, is roughly the same than having a solar panel on your roof compared to a nuclear power plant in your garden. Many users of cloud services perceive cloud as very simple. You know, it's user-friendly, you go out, you select the services you want, you click 3 times, it's up and running. That's one of the major advantages of cloud. But in the background, these services are extremely complex to be produced. And every service has its own DNA again, and every provider has its own DNA again. And in order to know what the service does to your use case and what risk profile it has, you need to understand how the cloud works. We invested together with AWS huge amount of times to actually learn how the AWS cloud really works. And that helped us to identify the risks in a manner where we could say, okay, we have this risk, we take those measures, and together we can mitigate our risks to a very, very large extent. And this may, for many people, be actually surprising. My pitch is, you can go into the cloud with secret data, telecommunications secrecy, banking secrecy, official secrecy. My pitch is then, Cloud Act and FISA 02 is not a problem. It's absolutely minimal, this risk. Do I say this because I want to hear it from myself, or am I convinced that it is the case? Now, if you think that I'm the DPO of Swisscom, and probably if something went ever wrong with that pitch, I would be the first to be indicted in criminal court, you may understand that I have a huge potential personal interest not to end up there. So I need to be really convinced that this is true. So how do we get there? We did two things. On the risk side, we analyzed the risks, especially these secret service risks with FISA, etc., in two instances. First, we did a legal analysis on the US surveillance law. And secondly, we did an analysis of how the cloud really works. So to give you a flavor of that, we asked ourselves, when we have data in use operating in the cloud, and for a little moment on the CPU, when the data is processed, it has to be decrypted. And once it's processed, it's going to be encrypted again. We fully control the key management, but on the CPU, this data is available. So we asked two things. Number one, under US law, surveillance law, does AWS have to produce the data from the CPUs in an unencrypted manner to the NSA or to any other law enforcement agency under US law? The answer under US law was no. There is no legal obligation to do that. Even if theoretically you could take the data from the CPU, there is no obligation to do so. Secondly, we worked with AWS and said, do we have any measures to make sure you don't do that? Even if you say you wouldn't do it, but we want to be sure from a technical point of view that you will not do it. And then, just for this example, you have the risk, you have the measures, and then you end up and say, okay, CPU data extraction is not a problem. We will not be criminally liable for this. And so we went all through the risks, which absolutely took time, and especially for our friends at AWS, it was a painful process, but they stick together, and so we built the entire framework, which allowed really to get now regulated workloads into the cloud without being awake at night, because I fear from a criminal conviction. In order to get there, you need to team up with the provider. There is no way you can do that by yourself. Why? Because you simply have not knowledge to understand exactly how the cloud works. And even if you read the thousands of pages they produce on the internet on that, you will always have very important questions like the CPU question, which they need to fill you in. So partnering, I thought, was the absolutely crucial success factor in this journey. And lucky enough, AWS stick with us for almost 3 years. So we went through all these painful meetings, all these painful processes, and I'm sure at the beginning they thought, this guy is crazy. However, I had a very good reason. First, I wanted to make sure that the data is secure, even in a decade or 2 decades' time, because I think this is my duty to make sure that the data of everyone else is safe. And this includes, by the way, your own data and mine. And secondly, I wanted to make sure that we don't hit any problems with law enforcement in Switzerland, or with customers, or with the public. And this is, by the way, the reason why I'm here today, because I want to democratize this journey. And last but not least, stay in control. Once the data is in the cloud, you need to make sure everything runs smoothly. And this also means that you have the power plant in your garden, you are on this board, you pull the plugs, you turn the knobs. And this means that really you need to have the operational structures in the organization. You need to have the people who understand what they're doing. You need to make sure that these are the right things you do and you don't do the wrong things. And then you need to have contracts. And Ruben also mentioned it. Contracts are important, not especially for the partnership that much, but for the rest of the world. Our customers ask to see those contracts, or it's law enforcement who will want to see whether we have the right stuff into the contract. So that was a journey in itself to actually renegotiate the contracts they had at the beginning to make sure we have everything in there which we legally need to have. So what are my takeaways in the end? Number one, you need to know the landscape you're working in, your own landscape, and you need to invest. Many companies don't have that knowledge yet. So I think it's worthwhile to invest in that, because only if you know exactly what your use cases are like, you're able then to make sure the cloud journey works in the right ways. Invest in IT inventories and data management, including tools. Number two, the applicable rules are manifold, multidimensional, and use case specific. It's not just the GDPR, it's not just the Swiss Data Protection Act. There is a myriad of laws out there which govern information, and they get more and more every day. So in order to reduce complexity, for many companies, they don't have the resources to do it exactly the way we do it. So in order to reduce complexity, it's good to make groups of use cases, to say, okay, this group has this DNA and we treat it like that. This group of use cases has another DNA and we treat it like that. Don't try to work on every use case individually. Potentially, if you do the right things, it's going to kill you. Number three, there is a certain risk that you lack the skills within the organization to actually go through that journey. Maybe you lack the cloud knowledge. Maybe you lack the knowledge of the own use cases. So therefore, we found that establishing a dedicated cloud team, partnering with the different hyperscalers, is the most efficient way to do it. So it gets to a one-stop shop rather than a decentralized approach where everyone is supposed to know everything, because it's so big. Number four, you need specialized skills and knowledge. In my case, I had to work through all these different technical issues in order to make sure I do halfway understand what's happening, because I can't take my decisions if I don't understand the techniques. So it included me and also other people like security architects, enterprise architects. They needed to work on that, and it took us a while to really get to speed where we are today. And last but not least, you need standard agreements which make sure you have everything you need to be able to show to the outside world, apart from security measures, apart from doing the due diligence, hey, we have a contract which is safe and it's supposed to do what it really can do. And therefore, partnering again with the cloud providers, they've come a long way, not just AWS, but other cloud providers too. They have heard the message, especially in Switzerland. They have come a long way to serve us on this point too. With those words, I wish you a very successful cloud journey. Again, I am convinced that hyperscaler clouds are really, really worthwhile. However, they come with a lot of homework, not so much on their end, but more on your end. So that's a painful journey, but it's feasible. Thank you.
Here today. Good. Maybe a quick show of hands. Who of you has actually migrated regulated workloads to AWS? Ooh, okay, nice. Good. Interesting. Sorry, let's move ahead. So we go a bit into more depth and we show you how we helped Swisscom to tackle all these challenges together. We built this framework and a blueprint. Let's have a look at it. Very similar to what Nicholas has talked about, but we will focus on two aspects: risks and regulations. And how do you come from risks and regulations to requirements? You have on the left side the risks. You need to define a list of risks. They can materialize, they can be internal and external, and they can have an impact. So you need to understand those risks, as Nicholas showed you. Then you as a company, you need to define your risk appetite, right? You want to take those risks, you want to move that data replication to cloud. On the other hand, you have the legal aspects, the regulations. So if you're security and compliance specialists, you look at the laws, the legal aspects that you need to abide to. Then that in combination gives you requirements. Why requirements? Okay, a risk can be data exposure. So you turn it into requirement. Avoid data exposure or avoid access to data. That's going to be your requirement. Then it's again shared responsibility. AWS has contractual commitments, agreements here in place for you to use, and of course technical controls. And you use those technical controls and contractual agreements to reduce risks. So at the end, you have a set of residual risks. So you mitigate risks or reduce risks. That again shows a bit how this process works that Nicholas has so nicely described. Now, how do we then move from requirements to controls? What are those controls? We have external frameworks like the MITRE ATT&CK cybersecurity framework that helps you understand what cybersecurity attacks are, how they map to AWS services. We have AWS well-architected documentation with a security pillar that goes into a lot of details, has a lot of design and controls and guidelines of what to do with security on AWS, whether it's on the AWS services or organizational implementations you can do. And of course, AWS services have individual security sections that help you understand what the service offers regarding to security. So, as Nicholas said, please, you as a customer, it is your responsibility. You need to understand those, but of course, AWS is here to help and support. Then as well, we have lots of reference architecture, like the security reference architecture, compliance reference architectures on our architecture center. So have a look at those as well. Then you have already a sense of controls. Ruben mentioned those, the Nitro control or the Nitro system, the AWS security services, here just a few. There is many, many more. And of course, as mentioned, every AWS service offers a lot of security and encryption possibilities. So let's look at the framework a bit in more details. We built it around two key pillars, the design principles, so-called tenets, and these design controls, more technical controls. What are these design principles? They are non-negotiable. You need to abide to them. Like, access to data is the exception, or no human access at all costs. Or also that controls that you implement are actually not shared across layers. So what are these layers? It means that these layers are independent and have individual responsibilities, like the core layer you see on the left side. AWS and the region and the services has certain capabilities, features you can use, and controls you can use. On top of that, you build a so-called landing zone, a platform that is based on your enterprise standards. This already gives you actually a lesser environment or a different environment than AWS offers out of the box. You secure it already. Then on top of that, of course, on a platform, you put an application with data. But what are those controls that you can put onto these layers or use on these layers? Those controls are in 4 categories. Preventive controls that help you to actually mandate certain things to happen or prevent certain things to happen, like certain services to be used, or least privilege implementations. Then we have remediative and detective controls. So you can literally detect everything on AWS, every action. You can use tracing, logging, monitoring. You know what's happening on the platform up until your last bit and byte. Use those controls, because then you can use audit controls. Audit controls help you to use that data to build an audit framework against it, maybe specific requirements you need to look at or NIST frameworks. You can track those and check the compliance continuously or even in real time. The last are the service controls, service-specific features, controls that you can use. And of course, these are applied on the services in the region. Example could be you enforce a certain specific AWS region or a specific AWS service to be used. It is key you select a good balance between mandatory and optional controls, because some controls can introduce a bit of more complexity. So there is a good balance somewhere of which controls you should use. This is just an idea, don't take it as a given. Just some ideas which controls can be a bit more tricky to implement, but it's your job to evaluate that together with us. Like the Nitro control, as Ruben mentioned, very simple to use. It is actually there out of the box. No additional click you need to do. You select the right EC2 instances and Nitro is there by default. Then other controls, maybe like client-side encryption, of course, well, you need to do something on the replication. If it's not implemented, it means you introduce a bit complexity, right? But yes, you also reduce risks. But there is somewhere a balance of these controls, and you need to find a good balance between mandatory and optional controls. So let's go to the meat of it. How does Swisscom use this blueprint? There's a lot of controls, and these controls are mapped to the platform, to the layers, in this example to a platform, and to requirements. Let's look at the Nitro control. Nitro control has been mandated to be used. So where has it been applied? On the platform. The platform has selected that if you choose an EC2 or EKS instance, only EC2-based instances that offer Nitro can actually be used. And how does it map to a requirement? It maps to the requirement of non-authorized processing, or against infrastructure security and infrastructure tampering, or against data tampering, because again, Nitro ensures that no unwanted personnel has access to your data on AWS. A key control, and you see how you can map those. Last one, reference architecture of how a regulated application in Swisscom looks like. Again, we have different controls. Swisscom has actually many, many more. This is just an example. We do a region scoping. Regulated applications can only reside in a Zurich region, only use specific services. Data in transit is enforced to use TLS 1.2. Identity and access management has a lot of least privileges implemented, specific roles like no data access role. So you see, we come from these principles, from these controls, they have literally been implemented. Then, if you go layer below, as we mentioned before, Nitro, a key control that has been used and mandated to be used. And of course, on encryption side, data at rest encryption enforced, memory encryption enforced, and even actually instance flow encryption. Have a read about it. It's also by default on AWS if you choose specific instances, so communication between them is encrypted by default. And the last one is an example of a platform control, AWS backup, to be used to ensure immutability of data and actually consistency of data. So you see here a lot of controls mapped against the platform, the application, the data, what you can do. So we hope that you really understood how to do this, but quickly in a nutshell before we finish. You need to understand the risks and regulations, and you need to calibrate those risks. You need to create a risk register and derive requirements. Then you define these core tenets or principles, as we said, and these design controls based on our extensive documentation or frameworks available. Then you map those controls to the requirements and to the layers, as the example we showed you with Nitro, to the platform layer, to the control. And you need to find a good balance between mandatory and optional controls, because some controls might introduce a bit more complexity. At the end, if you can, implement some of these controls on the platform, on the landing zone, because then applications on top can actually benefit from those already without doing anything additional. Last, help the teams. They are here to adopt those controls. They're here to adopt these frameworks, help them to onboard, do a POC with an early adopter. This will help the others to actually do the same and build some governance around it, because laws, risks, security can change. So as we showed in the beginning, you need to revalidate those risks and requirements and maybe update certain controls. So hopefully we showed you a bit how you can actually bring regulated workloads to AWS. And please don't hesitate to reach out to us to help you in this journey. Thank you.